Can't see them, right? First question, question 9. Okay, question 9 is a piecewise function. Okay, the function's domain is from -3 to 5, both sides included, and its range is R. Okay, the function is, okay, the first part is 2 minus x. Okay, 2 minus x when x is greater or equal to -3 and less than 1. Okay, let's draw it on the graph. Okay, let's say this part is -3 and this part is 1. Okay, 2 minus x. When x is -3, 2 minus -3 is 5. Right, so we find the point 5. Okay. This scale is not exactly accurate, but later we will see why. And when x is 1, 2 minus 1 is 1. Right, so it's here. Okay, so this part is this. Okay, left-hand side is included. Sorry. Left-hand side is included. So here we use a dot, right? That means when x is -3, that point is included in this line. Okay, but the right-hand side is strictly smaller than 1. Okay, so which means the right-hand side is not included. Okay, so here we can't use a dot. Okay, we have to put a small hollow circle. Right, we have to put a small hollow circle here. Right, meaning that when x is exactly 1, right, that point is not on this line. Okay, that's the meaning of this. Okay, when x is 1, then what's the value? When x is 1, the function's value is 0. Okay, so we draw the point here. When x is 1, the function's value is 0, so here is a dot on the x-axis. Okay. Then when x is between -1 and when x is between 1 and 3, the function is square root of x. Right. So when x is 3, it's square root of 3. Okay, again, the scale is not very accurate. Okay, again, when x is equal to 3, right, it's not part of the graph. So for this graph, both sides, both 1 and 3 are excluded from the curve. Okay, and what does the curve look like? The curve is a hump. Okay. Curve is a hump. Then the last part, x minus 1 square, when x is greater or equal to 3, but less than or equal to 5. Okay, so here when x is 5, the result, right, when x is 5, it's 4 squared. The result is 16. Okay, the result is 16. Okay, then what about when x is 3? When x is 3, it's 3 minus 1 squared. Okay, that is 4. Okay, so when x is 3, it is 4. Okay, and the quadratic equation, it's like this. Okay, so these are the 4 different parts of the function. Okay, most important thing is about the boundary cases, right? Whether a boundary is included in a part or not. Okay, if the boundary is included, in the curve, then you use a dot. Okay, if the boundary is not included, is not part of the curve, you draw a hollow circle. Okay, so that's the first question. And then write down the range. Okay, the range of the function. So which means what fx, what value of fx can you take, right, in this function? So first, what's the smallest value you can take? It's 0, right? The smallest fx value is 0. Okay. But here, any value between 0 and 1, right? Any value between 0 and 1, it's not included in the function, right? For example, this value 0.5. You can't find any x that gives you the value 0.5, right? So what's the second smallest value you can take? Right? It's slightly greater than 1. Okay, so it's not from 0 all the way to 16. 0 is just zero is just 1 point. Okay, and, right? So in mathematics, when we talk about when we talk about sets, right, the end is the union, right, which is this symbol. Okay, and then the second smallest value is 1. Okay, but here's the thing: the value 1, you can never get value 1 from fx, right? Because here it's a hollow circle. You can never get value 1 from fx, so it's not included in the range. Okay. Then from 1, moving upward, right? Any value you can get it from fx. Right? Here it's from 1 to square root of 3, or here it's from 1 to 5. Okay, here it's 4 to 16. So any value between 1 and 16, you can get it from the function. Okay, and for 16, it's included. Right? It's included as part of the function. So this is the range. Okay, this is the range of fx. Okay, this is the range of fx. Do you have any questions for this first part, part A? Okay, second part. Second part, we can just read the limits from the graph. Okay, first, when fx, okay, part B. What if, okay, the limit of fx when x is approaching 0. So when x is approaching 0, okay, you can see where is 0, it's here. Okay, when x is approaching 0, right, the function is approaching this value, right? The function is approaching this value. So, right, what is the function now when x is near 0? The function when x is near 0 is just 2 minus x. Okay, so it's just 2 minus 0. It's 2. Okay, so you can easily read it from the graph. When x is at 0, right, this along the function, the value of the function is approaching this point. Okay, so you can do a simple substitution. Okay. When x is approaching 2, okay, when x is approaching 2, let's see, when x is approaching 2, right, the function is approaching this point, right, from both sides. Okay, the function is approaching this point from both sides. So that's why we can also do the simple substitution. Okay, when x is 2, x is between 1 and 3, so we use this. Right, this is the function fx. So it's square root. Okay, it's square root of 2. Okay, so far all just simple substitution, right? Third part, also simple substitution. When x is approaching 4, okay, you can see from the graph, right, when x is approaching 4, right, it's a function from both sides. They're approaching this point. So you can just do the substitution. It's 4 minus 1 square. Okay, it is 9. Okay, next one. Okay, x is approaching 1. Okay, however, we have 1 negative. So what does this mean? Okay, x is approaching 1 negative. So this means x is approaching 1 only from the left-hand side. Okay, if it's negative, 1 negative, that means this point is approaching only from the left-hand side. Okay, if it's 1 positive, that means it's only approaching 1 from the right-hand side. Okay, if nothing, if just 1, that means it's approaching 1 from both sides. Okay, it's a very important thing. Okay, let me write it down here. So if x is approaching a value a, right, with a negative, that means it's approaching a from the right-hand side. Sorry, from the left, from the left. Okay, from the left. When x is approaching a with a plus sign here, that means x is approaching a from the right. Okay, when without anything x is approaching a, then that means x is approaching this a from both sides. Okay. So this is very important. So and the second thing is what is limit? Okay, limit means when x is closer and closer to a, what is the value of fx? The value of fx is closer and closer to what number? Okay, that's the meaning of limit. So when x is closer and closer to 1 from the left-hand side, from the left, then fx is closer and closer to what value? Okay, we can just read it from the graph. When x is closer and closer to 1 from the left, what the value fx is closer and closer to this value, right? Okay, you can see it's moving in this direction. When x is closer and closer to 1, your y is closer and closer to 1 as well. Okay, it's not 0, right? When x is closer and closer to 1, your fx is not closer and closer to 0. It's not like this. The graph is like this. Okay. So that's why this is, okay, just read it from the graph, it's 1. Okay, how do you get 1? Okay, another thing is when x is approaching a from the left, okay, that means your x is always slightly smaller than the number. Okay, when x is approaching a from the right, that means your x is always slightly greater than the number. Okay, here we don't have any conclusion. So when x is always slightly smaller than 1, that means your x falls in this interval, right? X is slightly smaller than 1. Sorry. X is slightly smaller than 1, so that means you need to use this function. Okay, so that's why it's just 2 minus 1. Okay, it's 1. Right. Then the limit of fx when x is approaching 1 from the right. Right? This will be based on the same logic. It's approaching 1 from the right. Okay, you can see along this curve, your fx is approaching 1 as well. Okay, when x is approaching 1, your fx is also approaching 1. So this is just, okay, when x is approaching 1 from the right, that means x is always slightly larger than 1. Okay, x is slightly larger than 1. You use square root. Okay, it's square root of 1, so it's just 1. Okay. So the next part is very, very important. Okay, limit fx, x is approaching a, is equal to, let's say, a number c. Okay, if and only if, okay, the limit from the left is equal to the limit from the right. Okay, and is equal to this value. Okay, this is very, very important. So now, limit x is approaching 1 fx, right? It is what? Because the limit from the left is 1. Sorry, limit from the right is 1. The limit from the left is 1 as well, right? They give you the same value, so you can immediately write down the answer. Okay. Do you have any questions for this part? Okay, then the last question shows you, okay, a different case when limit from the left is different from the limit from the right. Okay, let's write it down here. So what's the limit of fx when x is approaching 3? Okay, now you can see 3 is like a cliff here. They're no longer connected, right? From the left, you're approaching this value. From the right, you're approaching a different value. Okay? So let's figure out what's the limit from the left first, right? The limit from the left, right? You approach the point 3 along this curve, right? This curve is square root of x. Okay, this curve is square root of x, so it's just square root of 3. Okay, and then the limit from the right, you approach 3. Okay, you approach 3 along this curve. Okay, you approach 3 along this curve. This curve is x minus 1 square, so it is 3 minus 1 square. Okay, it is 4. So the limit from the left is different from the limit from the right. Okay, so that's why this limit, what's the conclusion? This limit does not exist. Okay, this limit does not exist. Okay, in the exam, usually the first 3 are too easy, right? These are too easy. Usually, there will be some question like this. Some question like this. Okay. Do you have any questions about this part?